All right, we're talking about inverse sine and inverse trig functions. We start off with the inverse sine function. We've got a couple things about inverse trig functions. Number one, F inverse reverses the role of a function. So think of a function doing something, F inverse undoes it. The second thing is that function F must be one-to-one for us to have an inverse. One-to-oneness says that for each x value we assign one and only one y value, and you can do that vice versa. Every y value has one and only one x value. So what that means is if you have a graph of a function, then it passes what we call the horizontal line test. Now, the horizontal line test means that if we have any given function, you remember this from algebra, if you have a given function, if you draw any horizontal line, if it touches the graph more than once, then the graph is not the graph of a one-to-one function. So if it touches it at most once, that is one or less, and imagine a million, zillion horizontal lines. If the most times it touches your graph is once, then it in fact passes the horizontal line test and that function must be one-to-one. Now in general, trig functions are not one-to-one functions. Again, they have these periods that they repeat over and over and over again, so that trig functions do not pass that horizontal line test. However, what we can do is we can restrict the domain of a function to make it one-to-one. If we restrict the domain of, say, sine inverse, or the sine function, and look at sine inverse, we therefore could have sine inverse because if we restrict the domain of the function sine, say from negative pi over 2 to pi over 2, then we have a function that does pass the horizontal line test. So let's define the inverse sine function, then take a look at its graph. So the inverse sine function is the function sine inverse with domain negative 1 to 1 and range negative pi over 2 to pi over 2 defined by this rule. Sine inverse of x equals y if and only if sine of y equals x. So if we draw the sine function, right, the sine function looks like this, and this is one period of the sine function where we have negative 1, actually 1 and negative 1. And here's pi, and there's 2 pi. Notice that this does not pass the horizontal line test. So if we take a horizontal line, it'll intersect this thing an infinite number of times. So what we do is we restrict the domain of this. So normally the domain of the sine function is negative infinity to infinity. But if we restrict it just from negative pi over 2 to pi over 2, if we just talk about the sine function, that interval, from negative pi over 2 to pi over 2, well now it's a one-to-one function that passes that horizontal line test. So what we're going to try to do is we're going to look at using this right here, okay? The inverse function is when basically we're going to change the x and y's. We're going to look at that and note that if we restrict the sine function, we can talk about the inverse function, sine inverse. Okay, so here's the rule that we're dealing with right here. Sine inverse of x equals y if and only if sine of y equals x. So we have the sine function here. Again, if we restrict it from negative pi over 2 to pi over 2, it's got domain negative pi over 2 to pi over 2 and range negative 1 to 1. But if we look at its inverse, now its domain is from negative 1 to 1, and its range is from negative pi over 2 to pi over 2. That is, we interchange the x and y's. Over here, imagine this is the point 0, 0. So I interchange 0, 0. I still have 0, 0, so that's a point on this graph. Here I've got the point pi over 2, comma 1. Well, here, interchange pi over 2, 1 to 1, comma pi over 2. And if I interchange this number from negative pi over 2, negative 1 to negative 1, negative pi over 2, I've got this point. So our graph of the inverse function is here. Now, what I want to use is I want to use this rule right here to go ahead and look at finding sine inverse of 1/2, sine inverse of negative 1/2, and sine inverse of 3/2. Now, one of these things that is good to have your unit circle. And if you talk about your unit circle, I'm going to go ahead and put the unit circle here for us to take a look at. But I have my unit circle where we have memorized the properties of it. You know, those ones that are kind of key are these ones right here where I've got these points, square root of 3, comma, over 2, comma, 1/2, and root 2 over 2, comma, root 2 over 2, and 1/2, comma, root 3 over 2. And these are all different values given a corresponding t value of a given length. Well, if we're only talking about the function, the sine function in between negative pi over 2, then all I really care about is quadrant 1 and quadrant 4. Because here I have 0 to pi over 2. Here I have 0 to negative pi over 2. So negative pi over 2, this is going negative if I rotate this way. So I have negative pi over 2 to pi over 2. When I'm talking about the sine inverse, the only two functions that I'm considering, the only two quadrants I'm considering are that quadrant 4 and that quadrant 1. So if you keep that in mind when I'm solving these, it kind of helps and makes a little bit more sense. So let's take a look. I want sine inverse of 1/2. So what I'm looking for is, for what value does sine of something equal 1/2? Because that's why I'm using this rule here. This rule here. Sine of inverse of some number equals something. So this is the number. What number is it? It's the number whose sine of it equals 1/2. So that's kind of what I'm looking for right here, guys. Is I'm trying to find out for what number here can I put in so that sine of it equals 1/2. What we're looking for then is, when is the y-coordinate 1/2? Well, when is the y-coordinate 1/2 in quadrant 4 and quadrant 1? Well, the y-coordinate's 1/2 right there, isn't it? Now, we have over here, we've got this, mirror image over here. This is root 3 over 2, comma, negative 1/2, and so forth. But the only time on this unit circle that in quadrant 4, quadrant 1, that we have the y-coordinate to be 1/2 is right here, and that of course corresponds to a length of pi over 6. So that's pi over 6. What we're looking for right here is pi over 6. So that means this value, we know sine of pi over 6 equals 1/2, therefore sine inverse of 1/2 is pi over 6. Okay? So that's one of the things that we go through, is we kind of think about it in the other way. Here we go, sine inverse of negative 1/2. So if I have sine inverse of negative 1/2, I'm looking for what distance in quadrant 1 and quadrant 4 allows us to find sine of it equals negative 1/2. So sine of what number equals negative 1/2, right? So sine of what number? Well, sine of what number? Well, if we go negative pi over 6, negative pi over 6 gives me the y-coordinate negative 1/2. Okay, so negative pi over 6, therefore that is equal to negative pi over 6, okay? And then finally, if I want sine inverse of 3/2, note that 3/2 is not in the domain of sine inverse, so this is undefined. Whenever we have a number in here that is larger than 1 or smaller than negative 1, then it's not in the domain and we say it's undefined. Okay? Good, so let's now take a look at the cosine inverse function. Okay, we're talking about the inverse cosine function. So the inverse cosine function is the function cosine inverse with the domain negative 1 to 1 and range 0 to pi, and it's defined by the rule cosine inverse of x equals y if and only if cosine of y equals x. So let's kind of motivate this by again drawing the cosine function. Well, if I draw that cosine function, here we go, 1, negative 1. If I draw that cosine function, it looks something like this, and then of course I continue it over a 2 pi period. But if we restrict that domain from just 0 to pi, then it's now a 1-to-1 function. Okay? Or if we drew it, it would have been 1-to-1, it wouldn't have passed the horizontal line test. Now we've restricted it from 0 to pi. Now it is in fact a 1-to-1 function. So then what do we get for its inverse function? What's its inverse function look like? Well, it's very similar right here. So again, where we had 0, 1, now we got 1, 0, correct? And here we had pi over 2, 0, so now we're going to have 0, pi over 2, and then if we have pi, comma, negative 1, now we're going to have negative 1, comma, pi, and so it looks something like this, okay? Good, so that allows us to draw the cosine inverse function, and then let's use that unit circle again to look at finding cosine inverse of root 3 over 2 and cosine inverse of 0. Now, the way we're going to do that is now we've got to know what quadrants are we restricting our cosine function to. Well, we've got our unit circle, and we only want, to make sure it's 1-to-1, we only want it between 0 and pi, so that means we're in quadrant 1, and we're in quadrant 2. So we only want to talk about those special values inside quadrant 1 and quadrant 2 to make sure that it is a one-to-one function. Okay? So, fine. So what's cosine inverse of root 3 over 2? Well, it's the number whose cosine of it equals root 3 over 2. Well, cosine is the x-coordinate. So when is the x-coordinate root 3 over 2, but only in quadrant 1 and 2? Well, over here the x's are negative. Over here the x's are positive, correct? So the x-coordinate of this one is root 3, comma 1/2, and that's the length of pi over 6. Now notice, yes, there is a point right here whose x-coordinate is root 3 over 2, but it's not in what we define, what we restricted our domain to be, from 0 to pi. So we know that this must be pi over 6, hence that is pi over 6, okay? So hopefully that sinks in and we kind of understand that. Good. Let's do cosine inverse of 0. So when is the x-coordinate 0 in, for what value length around my unit circle, do I have the fact that my x-coordinate is 0? Well, my x-coordinate is 0 right here in quadrants 1 and 2. And so we want the cosine who's of some number that gives us 0. Well, it turns out that that's going to be pi over 2. That means that's pi over 2. Okay? So we can do, again, this is just using the unit circle, and we're basically interchanging x's and y's when we look at that cosine inverse and that sine inverse function. Now I do want to put down some cancellation properties.